fuel monitoring and how to do it right. Fuel takes up to 50% in the expense pie of every business that operates a fleet of vehicles. Drivers know plenty of ways to steal fuel and rip you off, but there is a way to stop it. With accurate fuel data, you can save up to $7,200 annually for each vehicle. Yes, each vehicle. Fuel level control provides information on refuels, drains, and actual consumption, empowering you to collect accurate data on your fuel operations. You will have to compare this data with gas station checks and driver reports for future analysis. The industry offers a whole range of solutions for better fuel practices, including flow-type sensors, Canbus injector plus float sensors, ultrasound non-invasive sensors, capacitive sensors. Let's see what pros and cons they have. Flow-type sensors. Special small turbines hit the fuel pump drive of the vehicle. The flow meters read the value of the direct cold flow towards the engine and the value of the hot flow on its way back from the nozzles. Even though this system provides fuel level control of acceptable accuracy, it decreases over time and distance traveled. Also, these sensors do not account for events of refuel or drain or the fuel volume that is left over in the tank. Flow-type sensors are not easy to install. They require highly skilled personnel and specific fittings and hoses. You also need to cut into the fueling main to embed the sensor and its fittings, which puts warranty at risk since it is prohibited by auto manufacturers. Plus, the sand grains easily block the flow meter, not taking long to disable the sensor. Canbus injector and float-type sensors. The controller area network bus is the nervous system of a vehicle, connecting sensors with the onboard computer. The Canbus injector sensor delivers information on fuel injections into the engine cylinders, helping to measure fuel consumption during the drive. The Canbus float sensor evaluates how full the fuel tank is. Canbus sensors are relatively easy to install, and using a combination of both helps you determine when and for how long the vehicle was moving, when it was fueled, as well as how full its fuel tank is. Unfortunately, reliable results are only guaranteed when the sensors are installed on new or near-new vehicles that travel along good quality roads over flat terrain. Steady rate of traffic is a must, too. Plus, standard float-type sensors cannot deliver information in liters. In order to get liter-based data, it is essential to calibrate fuel tanks. The accuracy of Canbus injector sensors is easily undermined by multiple factors, such as driving style, fuel equipment quality, injection nozzles quality, fuel line pressure, atmospheric pressure, air strainers quality, fuel viscosity, and others. Inaccuracy increases with operation time. The serious drawback of Canbus float sensors lays in the two blind spots that cause up to 20% error of the value of the total refuel. It's too easy to compromise the readings of the Canbus injector sensor. Plus, the Canbus float sensor is limiting your options too. It doesn't let you evaluate the exact refueling volumes. It requires you to calibrate the tank separately for information in liters. It is not that reliable for long-term data aggregation. Ultrasound non-invasive sensors. The sensor measures the time it takes for an acoustic wave to travel from the bottom of the fuel tank to the surface of the fuel inside it and back. The wave frequency is chosen to make sure it can easily penetrate the side of the tank. The sensor is attached underneath the fuel tank on its external side of the bottom wall, and there's no need to drill or deform the fuel tank in any way to install it. This seems to be a big plus. The installation process, however, is complicated. First, you must find the perfect spot to attach the sensor, which may not be easy given the signal echoes, the uneven metal texture of the bottom of the tank, and/or any additional structures inside. Second, the acoustic glue needs 24 hours to set, and all the while, you should keep the vehicle in a stable, warm environment, exerting stable pressure on the sensor to fix it tight. Otherwise, the glue may deform, which may lead to low accuracy. Third, as this sensor is installed really low, it is constantly at risk of being knocked off by stones, water, or sidewalk edges. Drivers often try to get rid of the sensor, blaming it on the state of the road. The major pitfall, though, is the actual measurement accuracy. Whenever the road is bumpy or downhill or uphill, the acoustic signal gets lost because of the tilt of the fuel tank. Capacitive sensors. Coming from the aviation industry, this is by far the most popular fuel level monitoring technology and the most accurate one too. Its main principle of operation is measuring the capacity of the condenser as it fills up with fuel. The condenser itself is a coaxial type probe. They are highly accurate and reliable. There are no mechanical parts involved in their installation, and there are no blind spots to the readings of any kind. Moreover, they do not require technical maintenance over their lifetime. There are certain downsides too, however. Installing this sensor requires cutting into the fuel tank, and it only works with a single type of fluid originally exploited by the vehicle. Should not be a major problem though, as you're unlikely to switch fuel type that often, are you? With capacitive sensors, the advantages outweigh the drawbacks. That is why they are a true hit in the vehicle and transportation industries. Statistics suggest that there are by now over 1 million capacitive sensors installed on vehicles worldwide. Plus, you should not be worried about the warranty implications of cutting into the tank. Briefly speaking, the only element of the vehicle you're reworking is the fuel tank, and the vehicle manufacturer may indeed refuse warranty services associated with it. However, in no way can a drilled fuel tank be the direct cause of faults with, say, dashboards or the braking system or the suspension. Therefore, your warranty risks are limited. Your ideal fuel monitoring solution must fulfill the following criteria: deliver both fuel level and fuel consumption data, deliver accurate data that can be analyzed, provide reliable information, operate in a range of conditions, hot or cold weather, smooth or bumpy roads, etc. Do not spend money on solutions that give you incomplete data or data that you don't need. Go for the technology that guarantees maximum accuracy and is reliable in most situations. This is your business and your resource efficiency, and any data discrepancies or faulty device issues will cost you money. Omnicom has been designing fuel-level sensors and related equipment for nearly 20 years, having installed 800,000 sensors worldwide and integrated monitoring systems that deliver results with a solid 99.2% accuracy. Omnicom is always happy to make new friends. Get in touch and see how we can make you and your business efficient and, yes, happy.